probability of reaching orbit is good, probably 80%. It's certainly the third flight is a much better rocket than flights 1 or 2. But there's always you can't have too much luck in a rocket launch. We're getting ready to do flight 3 probably in about I guess the second week of March. Like normally it's like March 8th. We're trying to get it to be sooner than March 8th, but my guess is it happens sometimes in the first half of next month. And then flight 4 is ready shortly thereafter.
So then let's look at flight 2.
Booster engine cut off. Stage separation.
Flight 2 actually almost made it to orbit. In fact, ironically, if it had had a payload, it would have made it to orbit. Because the reason that it actually didn't quite make it to orbit was we vented the liquid oxygen, and the liquid oxygen ultimately led to fire and an explosion. Because we wanted to vent the liquid oxygen because we normally wouldn't have that liquid oxygen if we had a payload. So, ironically, if it had a payload, it would have reached orbit. And so I think we've got a really good shot of reaching orbit with Flight 3, and then a rapid cadence to achieve full and rapid reusability. And I mean, the mind-blowing thing is, like, there is an actual path that we are on to make life multiplanetary. Anyway, so in terms of getting there, we obviously want to accelerate the production and testing, get to a high cadence. For any given technology development, it is, how many iterations do you have, and what is the amount of time between each iteration? So every time we launch, or do a test, we learn something more. So increasing that cadence of launching and testing, and it's always better to sacrifice hardware rather than sacrifice time. Like, time is the one true currency. It's sort of the fastest path to, as I was saying earlier, rapidly reusable, reliable rocket. Yeah, and so with flight 1, the goal was not to blow the pad up and ideally get some distance, which we did. With flight 2, it was to get past staging, so we achieved the goal of getting past staging and almost to orbit. And then flight 3, we've got we want to get to orbit, and we want to do an in-space engine burn from the header tank and prove that we can reliably deorbit. We want to do a tipping point header domain propellant transfer. This is important for the NASA Artemis program. The mass orbit ultimately of Starship will be, over time, I think millions of tons of payload to orbit.